vulnerabilities, secure storage, and training and up-to-date tools. With layer security, you have a DMZ, and a DMZ is a buffer that separates the external net from the internal net. It's called a demilitarized zone, and a demilitarized zone is like a neutral ground. It doesn't allow people inside, it doesn't allow people to get outside. However, in DMZ, whenever it comes to a network, what it does is it stops people from the cloud from coming all the way into your network. But at the same time, it allows the people on the inside of the network to go outside and browse the web if needed. Most of the time, the DMZ has a web server in it. And what the DMZ allows you to do is, whenever you access YouTube, you're accessing a portion of their DMZ. That way you can view what it is that they want you to view, but yet you're not able to go inside and see what servers they have, what PCs they're running, or possibly what switches or routers they're using. IDS and IPS stand for Intrusion Detection System and Intrusion Prevention System. They're extremely important. There's two different types of them. You have host-based, which host-based means it's on every computer. And you have network-based, which means that the network one is at one position. Sometimes it's at a proxy server. With IDS and IPS, the Intrusion Detection System will detect if there's a malicious activity inside of your network. To turn an IDS into an IPS, all you have to do is implement some sort of prevention. That prevention might be shutting off a port, shutting off the NIC, so that way, once there's a malicious activity on that computer, it shuts down the NIC, so that way people aren't able to do anything on that computer anymore. The next type of security that we have has to deal with the denial of service, distributed denial of service, the ping of death, and the ping flood. All four of them are pretty much the same, but with a little bit different. The denial of service and the distributed denial of service is where an attacker, tries to shut down a web server, where they're basically trying to stop the server from giving off the normal functions that it needs to give off. The difference between the two is distributed uses a host of computers, and these hosts of computers are called zombies. And what it does is a hacker will take over some user's computer. It could either be within the same network or not within the same network. And then once your computer is taken over, it sends a ping to a particular place, say www.google.com. And it does this with the hope of interrupting their service, so that way users will stop using their service as much. The ping of death, however, sends a packet that is so large that the computer, router, or switch doesn't know what to do with it. Most ping packets are anywhere from 50 to less than 90 bits. With the ping of death, they go up to 65 megs, so it's exceeding that amount. Ping flood is where somebody sends a large amount of packets in a particular direction. And the reason why they do that is for the hope of shutting that system down, to causing it to reboot, where it sends so much information to the computer that it doesn't know what to do and it has to shut down. Next we have hardening. The purpose of hardening is to remove unnecessary software. Whenever you buy a new computer, usually whenever you buy a new computer, it has a lot of stuff on it. Free trials, this program, that program, things you don't use, things you probably never ever use. With hardening, you get rid of all that stuff, so you have a clean slate. The purpose behind that is to close as many security holes as you can. Also, in hardening, we have firmware. Firmware is a bit of software that is in most motherboards and most chips that tells the motherboard how to operate, what to do with what information and how to do it. With firmware, you need to update your firmware. However, with firmware, you typically don't update the firmware unless it's needed. If there is an immediate security incident and that people need to update their firmware to keep from having that security incident happening on their computer. Or if you install a new type of system or a new chip, maybe a PCI card onto your PC, and then it's not compatible. Well, updating the firmware could fix that. Next thing is control account access. And on controlling account access, this rolls back to the RBAC, the MAC, and the DAC. This is where you want to make sure that accounts don't get into information that they don't need to get to. You want to lock it down so that way accounting can only access accounting. Business can only access business. And that the IT staff isn't abusing their rights and accessing things that they don't need to be accessing. Network ports. Network ports need to be disabled because the reason why you want to disable network ports is If you leave FTP open on your port 20 and 21, people can telnet through FTP or FTP straight into your network and then do what they need to do. Another port that you might want to disable is telnet. Telnet is an unsecure protocol, and it allows you to access another person's computer and be able to control. Every time you click the mouse or every time that you open up an icon, you're using a telnet command. So if you're able to do all that through telnet, you want to be able to disable that so people don't log in to your computer and perform actions that you don't want them to. Antivirus. Antivirus is very important, and it allows you to stop worms, trojans, malware, or possibly viruses from getting onto your computer. You want to make sure that your antivirus is up to date. If your antivirus is a week old, it's not such a big deal, but you do want to get it updated. You want to make sure that it stays up to date and that you're not getting viruses. One incident with a virus, everybody knows about the Target incident. Well, the Target incident was actually a Trojan, and that Trojan's name was Zeus. And Zeus was actually designed so that way it steals banking information, but instead they loaded it onto the Target network, and then once it was loaded onto the Target network, it was able to take care of and take everybody's credit cards. That's one reason why you want to make sure virus software is up to date. Penetration testing. Penetration testing is very important. It allows you to simulate attack on your network. It's also designed to look for vulnerabilities. A vulnerability, for instance, would be an open port. With a penetration test, it finds these vulnerabilities and then it allows you to block them up. That if you might have to have FTP open for cameras, something like that, but do you have to have FTP open on your outside router? That could be a security risk. So therefore you would close those ports on your outside router going to the internet, but then keep it open on your intranet. So that way it's open inside of your company. Vulnerability assessment is designed to find vulnerabilities and weakness inside the network. These vulnerabilities could be simple. They could just be patches, updating patches. Adobe, at one time, they released an update, and the update was specifically designed to close a back door that Adobe forgot to close. It happens all the time. Microsoft has actually made updates that cause people issues and acted like a virus. So you want to be aware of this, and you want to actually read through the updates as you implement them, but you want to make sure that your computer is up to date as can be. The purpose of a vulnerability assessment is to keep it up to date, to close the weaknesses, and to make your network secure. So that way people aren't just coming into your network and then doing as they want. Another thing that you might want to check for instance, is autoplay. An autoplay is whenever you put in a CD or thumb drive into your computer and it automatically execute what is ever on that CD or thumb drive. That's also how Target happened. The Target incident happened. They plugged in a thumb drive and then it executed a virus onto their network. It saw that it was an exe and then it just ran and did what it needed to do. Next thing we have is secure storage. And secure storage is very important. Whenever it comes to a network, the data in the network is the most important part of the network. You want to make sure that that storage is encrypted. You want to make sure that you're performing backups on that network. That the encryption, you might use something, for instance, TrueCrypt, which TrueCrypt is a program that's designed to make encrypted containers for you to put information in, or you can use it to make your whole entire drive encrypted. The reason why you would want to encrypt a hard drive is in case that laptop or that computer is stolen. And then once they get that computer, that they'll open up that hard drive, try to go inside of it, and they won't be able to access it because it's encrypted. All they'll see is just one large file, or they'll see garbage, and they won't be able to access what your company has, the company's secrets. Accounting information is very important. And if a hacker gets accounting information, they can do extremely bad things to your company. Training. Training is extremely important, and the purpose behind training is to keep IT up to date on current technologies throughout the world. Cloud Plus wasn't very big a few years back. However, now it is getting really big. Back in the 90s, most people didn't have a computer inside their house. However, now everybody has a computer. A company cannot do anything without a computer. Even the companies that you think don't use computers, they have some form of technology, whether it's their phone. For instance, a heating and air company. And heating and air company doesn't really use a lot of tech stuff, but they keep a database of their customers. They have phones. The service representatives have phones. And on top of that, the stuff that they use to bend the sheet metal to make the ductwork for the AC, well, that was invented with technology, that they still had to have a computer make that equipment so that way they can make the things that you need to get AC inside your house. Having up-to-date information is very important inside of any network whenever it comes to IT. The other part on training and up-to-date is having the correct up-to-date software. If your company is using Microsoft 2003, they're pretty far behind. However, if they didn't know that Microsoft 2010 came out, then they would never migrate it up to it. So therefore, keeping your IT staff up to date and getting the new software as it comes out. For instance, if you have PST files, well, if you have PST files created from 2000, you're going to have issues plugging them into Outlook nowadays, that some of them will not work because of the way the network was designed or the way that the program itself was designed. So keeping the information up to date is very important. The last part of this is rapid deployment. And the purpose behind rapid deployment is to get the software and then issue it out. So that way it's available to the customers as quick as possible. Databases are very important. Whenever it comes to database, you have Oracle and MySQL, the two leading ones. Well, with rapid deployment, that allows you to get the newest database program and to get your information up to date and then send it to the customers as quickly as possible. The purpose behind rapid deployment is to stay up to date and to give your customers what they need when they need it. High availability is very important. With high availability, you have fault tolerance, multi-patching, and load balancing. Fault tolerance is very important. Fault tolerance is primarily used with hard drives, and the purpose behind fault tolerance is so that way, if a hardware fails, you're able to replace it without having a loss of service. We talked about RAID, and the purpose behind each RAID is so that way you have high fault tolerance. RAID 5, for example, if you lose a hard drive, you're able to continue on until you're able to replace that hard drive. A lot of times, companies will have something called a hot spare, and a hot spare is where you have a ready standby instead of where you're using 3 RAID hard drives, RAID 5. The 4th RAID hard drive that you have implemented will automatically pick up whenever one hard drive is removed or fails. Geoclustering is another very important aspect whenever it comes to fault tolerance. The purpose behind geoclustering is so that way you're able to have multiple sites at multiple locations. For instance, Google has high geoclusters. They have one in Washington State, they also have one in China, and they also have one in the Middle East. So that way it provides many customers with the ability to connect to what they need to connect to. Multi-patching is very important. What multi-patching allows you to do is to have many ways to connect to a storage device. It allows for redundancy, and redundancy is extremely important whenever it comes to the customers getting what they need when they want it. That if you go to sign on to Google and it says Google is unavailable, well, you're probably not going to use Google then, you're going to move to somewhere else. And then once you move to somebody else, say for instance Bing, you're going to continuously use Bing. That you're not going to rely on Google anymore. The next one is load balancing. And load balancing is designed to distribute the workload. Say for instance in your network you have 2 routers. And the 2 routers distribute the workload of sending out the packets so that way it's not just one router being overwhelmed. Is it easier for you to read a 100-page book and then recite the whole 100-page book? Or to take the 100-page book and divide it between 2 people, 50 and 50, and then for them to decipher the 100-page book? Recovery. Next thing we're going to talk about is recovery. And with recovery, we have disaster recovery methods, multi-site configurations, backup and recovery, and then snapshots. The next thing that we have is disaster recovery methods. With disaster recovery methods, the first 2 are the mean time between failure and the mean time to repair. The mean time between failure is whenever a device is going to die. The best example that I can think of is with a projector. A projector has a light bulb, and that light bulb has a life. Well, once the life reaches 0, the projector shuts off to keep the projector from being damaged. That would be MTBF, and that keeps the device from causing hardware failure inside the projector itself. The next thing is MTTR, and the MTTR is the typical amount of time it takes to repair a failed component. For the projector, it would be maybe a few minutes to repair the light bulb, to take a light bulb out and put a new light bulb in. However, that would still be part of the MTTR. For other devices, say for a switch, the switch could take a long time to switch out. Switches are extremely heavy, so whenever you're replacing a switch, you need to have 2 or 3 people there. So therefore, you might have to schedule downtime, schedule the outage, schedule people to meet up at the exact same time, so that way you can get that switch into its correct place and then be able to set it up. That would be the MTTR. The next method is with RTO, or Recovery Time Objective. And Recovery Time Objective is the time in between the outage and the restoration. The best example I have for this is with Exchange. Exchange is a database that allows people to access emails and to be able to share information via that way. Well, with Exchange, it does have issues and it does come down every now and then. Well, whenever it goes down, then you need to have a RTO, the expected amount of time that it's going to be to have Exchange loaded back on. That time could be a day or 2, or it could be a week, depending on what information you have. The last point is Recovery Point Objective, and that's the max time that data can be missed to the incident. Well, the max time could be set in place by the CEO or the person that is in charge of the company or the department. And that time could be a week. They might say, Exchange has died, so therefore you have 1 week to get it back online. And if you go past that 1 week, there could be issues with that. So you need to comply with the RPO. The other thing is with multi-site configuration. And the way to alleviate some of these other previous points is with multi-site configuration. Having a cold site, a warm site, and a hot site. A cold site is another place where if there is a disaster, all you have to do is take the PCs, take the hard drives, or take something, go to that new site, and you're able to continue on. Say there was an earthquake or a hurricane, and the building that you usually work out of is flooded or destroyed. Well, you're able to go to the next site, take a few items, take your laptop or take your gear, and then you're able to go to the next site and be able to continue where you are. A hot site, on the other hand, is where you take nothing. That is where once your building has been demolished or there has been a fire inside of your building, you're able to go to the next site and continue on. That you have backups at that place, you have site replication to that place, that you're able to continue and have no downtime. A warm site is in between cold site and hot site. A warm site is where you might have to take a few items, you might have to do a little bit. There might not be enough rooms for you to take everybody, but you're able to go back to that place and continue where you left off and with minimum downtime. Backups and recovery. Backup is extremely important. Without backups, ITs probably wouldn't even have a job. If you perform backups on your network, but then something happens and you lose all your backup data, or you lose the data that the users have, well, you're going to have huge issues and you might be out of a job at that point. So backup recovery, there are 4 things you need to remember about backups. There are full backups, incremental backups, differential, and then there's an image. Each one has a function that they need to perform. With backups, we have several different types of backups. You have the full, incremental, and differential backups. Whenever it comes to backups, most of the time you want to be able to get all your information restored as quickly as possible. A full backup will allow you to do that. However, a full backup can be large. If you have a terabyte of data, a full backup would be a terabyte of data. To alleviate that, they came up with incremental and differential. Incremental and differential are very good whenever it comes to restoring backup. Here's a good example. Say on every Sunday, you perform a full backup. And then throughout the rest of the week, you perform an incremental, an incremental, an incremental. And then you perform another full backup on Sunday. Well, with this setup right here, what happens is whenever you need to restore data, and say the servers crash on Thursday, and now they're gone. Whenever the servers crash on Thursday, you need to restore all your information back up to Wednesday. Well, to do that, you would restore your full backup from Sunday, then you restore your incremental on Monday, incremental on Tuesday, incremental on Wednesday. This keeps your backup small. That say, for instance, your full backup on Sunday was a terabyte, but the rest of the week, only 10 gigs of data was changed, well then each one of these backups will be 10 gigs. With incremental, you have to restore every day up to that point. The next type of backup is called a differential. And with differential, it's a little bit different. So say Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. You perform a differential backup. With this, say the servers die on Thursday also. Differential, all you have to restore is your full backup from Sunday and then your differential on Wednesday. What this allows you to do is to have less downtime. With incremental, you'd have to keep putting in a new device and then restore, and then restore, and then restore, and restore. With differential, you put in the tape for the full, and then you restore that back up, and then you restore the differential to the closest time to the disaster. One downfall of this is, say every day there was 10 gigs that was changed. Well, the differential this day would be 10 gigs. This day it would be 20 gigs because it would have Mondays and Tuesdays. This day would be 30 gigs because it had Monday, Tuesday, and Wednesday. Whereas incremental, it would just have 10 gigs from Monday, 10 gigs from Tuesday, 10 gigs from Thursday. So it allows you to be able to restore with the least amount of tapes, differential does, and incremental allows you to back up quicker. So that way you, in case backups have to have downtime. And then the last thing that we talked about was image. And what image is a complete backup of the server or of the computer. However, with image, it's a little bit different. Instead of a full backup and differential and incremental just being the data, an image is a complete mirror of that computer as it is in that state and time. Images most of the time are used with cloning and things of that nature, which we talked about previously. The last thing that we have is snapshots. And with snapshots, what that is used specifically with VMs. And snapshots allow you to capture the image of the VM as it is in that state and time. But it is not a replacement for backups. It allows you to see where your data was so that way you can restore it back to that point. It also has all data and files in the VM, but it's only meant to be used for short term. I would use it for about a month, use a snapshot for about a month. Other than that, backups are where you really need to copy your data. With VMs, as we talked about earlier, you can have many VMs on one host. You might be running 10 VMs on that one computer. But with backups, you'll be copying all the VMs. And with Snapshot, you'll be copying that specific VM at that point in time. Well, this lesson we described the access control, the information security,